All right, now we just were using solving for missing angles, but now we're going to have to do the same type of thing, but we're going to work with line segments. Now, factoring could come in with this one. It's not that bad. Just trust yourself a little bit, okay? But also don't forget Pythagorean Theorem and right triangles to help you out. So in the first thing in the direction it says, ray AB is tangent to circle C at point B. So that's your point of tangency. Find the value of x. So the first thing I'm going to do before I forget in every one of these diagrams is to draw in my what? If you said perpendicular angle, I'll be so upset with you. Remember, it's right angle. All right. Now, looking at this, I have to solve for x. And they're using the fact that the radius is the same size. Well, do not tell me you have a 30, 60, 90 triangle. That's not the case. You don't know that. So what you have to use is the Pythagorean Theorem. So with this one, I'm going to use leg squared plus leg squared equals hypotenuse squared. Now, leg is x squared. The other leg is 8 squared. But what's your hypotenuse? That better be x plus 2, not 2 times x. Guys, sum of the parts equal the whole. Not multiplication of the parts equal the whole. Sum of the parts. So we're going to put x plus 2 squared. Now, sidebar. If you cannot square the x and square the 2 and say you're done. You're going to have to use the process of distribution, FOILing. So I go x plus 2 times x plus 2, and I do that real quick. Outside ones multiplied together. Well, that's x squared. Front ones, excuse me. Outside ones multiplied together be plus 2x. Inside plus 2x. Last is going to be plus 4. So that's going to be x squared plus 4x plus 4. So we go x squared plus 64 equals x squared plus 4x plus 4. All right, so we have to make sure we do that correctly. And now I'm going to sit there, I'm like, oh, I might have to factor. No, you do not. Look what happens. What happens to my x squareds? There's been no illegal math here. They just went away on their own. So now I get 64 equals 4x plus 4. Sometimes, are you going to have to factor? Yes. In this case, did you have to? No. Gotta love it. I love it when math is beautiful. It's just gorgeous. All right. So when we're doing this one, let's look at the next one. Now, it looks like I only know 2 sides of that right triangle, or I don't really only know one, because this is 3 and a 7 here. But really, what do I know about the radii of a circle? They're going to be the same. So that's 3. All right? So if that's the case, can I go 3 squared plus x squared equals, well, the hypotenuse, and make sure you use the hypotenuse. Many people mess up the leg and the hypotenuse. Don't make me come unglued. Don't make me go teacher if you did your math wrong. Make sure you know the hypotenuse is always opposite the right angle, and that should be 10. Now, what I like about this one's sweet numbers. You get 9 plus x squared equals 100. You subtract 9 from both sides. You get x squared is equal to 91. Then I take the square root of it, and this time I'm remembering my plus or minus, but I look up here, and I can't simplify the square root of 91, and if I put a negative square root of 91 here, it gets the wrong answer, so my answer is the square root of 91. Ah, so beautiful. I just realized I forgot to solve the other problem. Guys, you have a mess for a teacher. Please forgive me. I got so excited that the problem was easy, I totally forgot about it. Ah, and I promise you, I had my coffee today. Oh well, let's go ahead and keep working on the other one here. Now, looking at this next one, am I going to use the fact that the radii of a circle are congruent? You bet, because they're always the same. So can I use the fact that this radius is 9? What's this one? 9. Now can anyone tell me quickly the measure of x? Did anyone say 6? You got it. Why? That's a 9, 12, 15 triple. your Pythagorean triples right there. So you literally could have said x plus 9 equals 15, x would equal 6. Now, what if you forgot that? Well, then your choice would be the following. Leg squared plus leg squared equals hypotenuse squared. You'd have 81 plus 144 equals, we're going to multiply it, FOIL it out, get x squared plus 18x plus 81. So then I would be working with this and I'd be solving for it. I'd actually pull it over and I'd get 0 is equal to x squared plus 18x minus 144. That would factor in using multiply, add, choose. You would have an x plus, an x minus, and your two numbers, I do believe, would be, if I make sure I got my math right correctly on here, 6 goes into 144 how many times? Double check me, my friends. I've been doing this a lot today, so I'm singing for absolutely no reason. Okay. 6 and 24, I totally forgot that. So I get plus 24 and then I get x minus 6. Then you have to set them both equal to 0. I get x is equal to a negative 24 and I get x equals to a positive 6. The negative 24, what happens? Can I have a negative 24 for length? No. Plus, if I had 24 in there, it messed up my whole thing. So it's gone. So your only solution is x is equal to 6. Now, don't you think it's easier to know your triples? This work versus that work. That's what I thought. Okay, now for the next one. This one's really hard, and this might be one of those things you come back to over and over again in the videos to make sure you're doing this right. But I tell you, if people don't do it the way that I tell you, they get it wrong. I'm sorry if that makes me sound really cocky, but the whole point is it works the way I tell you. If you don't do it the way I tell you, people get it wrong. Okay, so first of all, I'm going to use a common tangent. It's because line ZY is tangent to the circles. If I have a tangent line to a circle, I draw in the radius and I form two right what? Right angles. Now, what else are we going to do? We then have to somehow solve for the missing value. We're going to use right triangles and rectangles to help us do this. So the first thing you're going to do is that you are going to draw in from the center of the smallest circle a segment that's parallel, okay, parallel to your tangent. And that makes this a right angle. And then you have your rectangle. And we know the opposite sides of the rectangle are 25. And this would be 9. Well, if that's 9, that leaves this segment to be 3. So now I have this small, narrow, right triangle that I'm going to be using. And I just used the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. 3 squared plus 25 squared equals x squared. Now, x is the hypotenuse. Remember, it's opposite the right angle. So I get 9 plus 625 equals x squared. Well, that's 634. Guess what? No perfect square numbers come out of 634. So x is the square root of 634. I'm sure you're so excited. But notice how we draw it, and you're going to see me draw the same thing. And if you label your diagrams and mark them up, it helps so extremely much. If not, you crash and burn. Okay, you crash and burn. So let's look at the next one. Even though this is drawn a little bit differently, I have the larger one and the smaller circle. Their centers are connected. Now, I always will start at the center of the smaller circle, and I'm going to draw it so it's parallel to the common tangent, which we drew in with right angles. Well, if I draw it parallel to it, I automatically get right angles. And then I mark what I know. This leg is x. Now this segment was 2, which meant that one's 2, so that would be 1. So now I'm looking for a leg. Remember, this is your C. That's your hypotenuse right there. So leg squared plus leg squared equals hypotenuse squared. So I have 1 squared plus x squared equals 7 squared. So 1 plus x squared equals 49. X squared equals 48. Take the square root of 48. It should be 4 root 3. Now, This one is very easy. I gave you the two main examples that you're going to see, so please, please, please do not forget to know where the hypotenuse is of the small triangle. And actually, I'm going to just color this triangle in. Remember, you know which one's the hypotenuse, okay? It's these small triangles are what are we using to actually solve the problems. So use that to your advantage, but make sure you know the difference between a leg and a hypotenuse. All right, last one on here. And this one has like 4 or 5 examples in the notes. I will promise that will be on a test or a quiz, so make sure you know how to do those. The next one, we'll talk about 2 tangent segments. Now looking at that, what do those look like to you? They're what? The same size. Well, in fact, they are, and we'll talk about why in just a second. If 2 segments are tangent to a circle from the same exterior point, then the 2 segments are congruent. If 2 segments are tangent to a circle from the same exterior point, then the 2 segments are congruent. So basically, I'm supposed to automatically go and mark those 2 the same. Now, here's why. I'm going to do the Y in red. First, I'm going to draw the radii in to the points of tangency. And so I get these 2 right angles. Then I know the radii are congruent, correct? Then I'm going to draw this nice little line segment to that exterior point. Did I just form 2 right triangles? And do they have that common hypotenuse? Yeah, that's congruent. So by hypotenuse leg, the 2 triangles are congruent. So therefore by CP, CTC, so we'll go by HL congruence and corresponding parts of congruent triangles congruent, I know those 2, AB and AC, are congruent. That is like the coolest thing. Now here's a sidebar. If you ever draw a segment from the center to that exterior point, because of corresponding parts of congruent triangles being congruent, they are also congruent. And that's not, some books have that as a formal theorem, some do not. If you use that, I'm okay with it. So just keep that in mind too when you're working with these. All right, we actually have one more page basically of notes and a couple more fun examples to work with that.